Hello, I am Andres Carvallo, and I will present you the project Neural Language Models for Text Classification in Evidence-Based Medicine. This project was done with my advisor, Denis Parra, and in collaboration with Epistemónicos members Gabriel Rada, Daniel Pérez, Juan Vázquez, and Camilo Vergara. The motivation of these projects comes with the exponential growth of medical evidence related to COVID-19. There has been more than 200,000 new articles since the pandemic started, with 1,000 new articles every day, making the effort of physicians to check if the document is relevant increasingly difficult at every time. The collaboration with Epistemónicos is really important because they are one of the most prominent evidence-based medicine databases, which is validated by physician collaborators, and they have been curating articles related to COVID-19. The process consists in identifying relevant evidence where they are interested in randomized controlled trials and in systematic reviews. A randomized controlled trial is a type of methodology that takes a group, divide it randomly in two subgroups, and give them two different interventions, and then compare the reaction to this intervention between both groups. And the other type of article that is important for them are the systematic reviews that takes all the evidence related to one medical subject. The dataset provided by Epistemónicos consists in systematic reviews, primary studies non-randomized controlled trial, primary studies randomized controlled trials, a broad synthesis of a systematic review, or documents that were excluded for reasons like experiments were not done with humans. So our proposed model is a popular transformer-based language model called XLNet that, according to the title and the abstract, we predict the type and the study methodology. And depending on that, we decide to include it or not in the Epistemónicos database. Our baselines are a random forest, which is the current solution done by Epistemónicos, which uses a tokenizer based on the appearance of keywords to classify documents, and a BioBird language model, which is a bird language model pre-trained on PubMed full text articles. The results show that XLNet is better than the other models if we see the F1 score for each one of the classes. We also made an analysis of how the model is separating each class, and we reduced dimensionality using UMAP of the XLNet document representation, and we see that all of the classes are very well separated. So the results make us think of two hypotheses of why XLNet work better than the baselines. First of all, XLNet allows to use the whole abstract and is not limited to 512 tokens as BERT. So it can capture information from the whole text. The other thing that we think made XLNet work better is that they improved the training methodology using a permutation language model. So for future work, we want to implement a user study to evaluate if including explanations to the physicians to determine if the document is relevant or not will be relevant for them. So thank you very much, and see you at the conference.